In this video, we want to look at finding the determinant of a 3 by 3 matrix. So let's start off with our A matrix, which again is square and 3 by 3, 3 rows and 3 columns. The elements are 1, 0, 2, 0, 1, 1, and -1, 2, and 3. So to find the determinant of this matrix A, using the technique known as the Laplace expansion of a determinant, we first need to choose a row or column by which we will evaluate or expand the determinant. So let's start with, say, the first row. And the way we find the determinant of A is as follows. If we're going to use the first row, we take the first element in the first row and multiply it by its cofactor, plus the next element in the first row times its cofactor, plus the next element in the first row times its cofactor. So the determinant of A will be the sum of the products of the elements and their respective cofactors in a given row or given column. So what I like to do here again is I want to put a note to myself that we're trying to find the determinant of A using the first row elements. So here's how we do it. Let's start off with the first element in the first row, 1, times its cofactor. Well, what is the cofactor of this element? First row, first column of the A matrix. Well, the cofactor of that element is the signed minor of that element. So how do we find the minor of this element? You could think of it as the element A11 in the A matrix. We look at the subdeterminant of the A matrix formed after deleting the row or the row and the column containing that element 1. So we're going to have the determinant of the elements 1, 1, 2, 3. That's the minor of this element A11. And to get the cofactor of element A11, since 1 plus 1 is 2 and even, we have a plus sign attached to that minor. And this whole expression in parentheses gives us the cofactor of this element in the first row, first column of the A matrix. Plus the next element, which is 0, times its cofactor. So we have to first of all look at the minor of that element. How do we find the minor of that element? We look at the subdeterminant of the A matrix formed after deleting the row and column containing that element. So we're left with the elements 0, 1, -1, and 3. Now remember, we're looking at the cofactor. We're trying to find the cofactor of this element in the first row, second column, element A12. So since 1 plus 2 is 3, which is odd, we have to assign a negative number to that minor to get the expression in parentheses, which is the cofactor of element A12, so to speak. Plus the next element, 2, in the first row times its cofactor. How do we find the cofactor of this element? Call it element A13, the element in the first row, third column of the A matrix. We first of all have to get the minor of that element. So we have to look at the subdeterminant of A formed after deleting the row and column containing that element. And we're left with the elements 0, 1, -1, 2. And since this is the element A13, the cofactor of element A13 is the minor of element A13 with what sign attached to it? Well, 1 plus 3 is 4, which is even. So we attach a positive sign to that. So let's see if we can simplify this and see what result we finally get. The determinant of A is equal to the following. We have the number 1 times what number here? Well, we have to evaluate this second order determinant. And this comes out to be 1 times 3 is 3 minus 2, which is 1. And just for practice, let's do this. Minus times a plus is a minus, minus 0. So we can just call it plus 0 or minus 0 if you will. Times this second order determinant, which is 0 minus 1. So it's just going to be 0 plus 1, which is 1, plus 2 times the second order determinant, which comes out to be 0 plus 1, which is just 1. So our final result is 1 minus 0 plus 2, or 3. Now you should be able to also find this same number by evaluating the determinant of A using any other row or any other column.